Welcome to our channel. Today, we're diving into the fascinating world of time travel. For centuries, humans have dreamt of journeying through time, visiting the past and witnessing the future. What if I told you that the very fabric of our universe might hold the keys to unlocking this extraordinary ability? We often think of time as a river, flowing steadily in one direction. But what if we could navigate its currents, ride its rapids, or even step out of its flow entirely? We're going to explore 7 scientifically plausible ways to travel through time. From the mind-bending physics of wormholes and cosmic strings, to the reality-bending concepts of time dilation and quantum tunneling, we'll journey to the very edge of human understanding. Get ready to have your mind blown wide open as we explore the universe's most tantalizing mysteries. Before we embark on this incredible adventure, take a moment to like this video and subscribe to our channel for more explorations into the cosmos. Fasten your seatbelts, fellow time travelers, because things are about to get seriously mind-bending. Imagine a piece of paper, folded in half. Now imagine a tiny tunnel, a shortcut, connecting 2 distant points on that paper. That, in essence, is a wormhole, a theoretical passage through space-time. These cosmic shortcuts, predicted by Einstein's theory of general relativity, could potentially allow us to traverse vast distances in the blink of an eye. But here's the kicker. Wormholes might not just be shortcuts through space, they could also be tunnels through time itself. Imagine entering a wormhole and emerging not just light years away but also years, decades, or even centuries in the past or future. The very thought sends shivers down the spine. Of course, wormholes remain highly theoretical. Creating one would require unimaginable amounts of energy, perhaps even harnessing the power of exotic matter with negative mass. But the possibility, however remote, is enough to ignite our imaginations. Could these cosmic tunnels be the key to unlocking the secrets of time travel? The answer, my friends, lies in the ever-evolving tapestry of scientific exploration. Imagine the universe as a perfectly smooth fabric of space-time stretched taut like a trampoline. Now picture tiny imperfections in that fabric like minuscule cracks or wrinkles. These, my friends, are cosmic strings, hypothetical one-dimensional defects in the very structure of the universe. These cosmic strings, remnants of the universe's earliest moments, are thought to possess immense density and gravitational pull. And that gravity, according to some physicists, could hold the key to manipulating time itself. Picture 2 cosmic strings passing close to each other, their immense gravity warping the fabric of space-time around them. This warp, this cosmic dance, could potentially create a closed time-like curve, a loop in the fabric of space-time that could allow for travel through time. Now let's be clear. Cosmic strings are still very much in the realm of theoretical physics. We haven't even definitively observed them yet, let alone harnessed their potential power, but the possibility, however speculative, is a testament to the boundless wonders that the universe might hold. Could these cosmic threads be the warp and weft of time itself? The answer, like so many cosmic mysteries, awaits further exploration. We often think of time as constant, an unwavering metronome ticking away at the same pace for everyone. But what if I told you that time is relative, that it can speed up or slow down depending on your speed and proximity to massive objects? This mind-bending concept, my friends, is called time dilation, and it's one of the most well-established predictions of Einstein's theory of special relativity. Imagine 2 identical clocks, one here on Earth, and the other on a spaceship hurtling through space at incredible speed. According to Einstein, time would actually pass slightly slower for the clock on the spaceship relative to the one on Earth. This isn't science fiction, it's a real phenomenon that has been experimentally verified countless times. But time dilation doesn't just occur at high speeds, it's also influenced by gravity. The stronger the gravitational pull, the slower time flows. This means that time passes slightly slower at sea level than it does on a mountaintop, where the pull of gravity is slightly weaker. Now, while the time differences we're talking about here are incredibly small, they have profound implications. Time dilation suggests that time is not the rigid, unchanging entity we once thought it was, but rather a fluid, dynamic aspect of the cosmos. Chapter 4. Tipler Cylinder, a spinning gateway to the past. Imagine a cylinder of immense density, stretching infinitely long, rotating at near the speed of light. This, my friends, is a Tipler cylinder, a hypothetical object theorized by physicist Frank Tipler in 1974. Now brace yourselves because things are about to get really weird. According to Tipler's calculations, the gravitational field generated by such a rapidly spinning, ultra-dense cylinder would be so powerful that it would distort spacetime in a most peculiar way. It would actually create closed, time-like curves, those mind-bending loops in the fabric of the universe that we talked about earlier. In theory, a spacecraft following a precise spiral path around a Tipler cylinder could emerge at a different point in time, effectively traveling to the past. Now, before you start packing your bags for a prehistoric adventure, let's address the elephant in the room. Building a Tipler cylinder is, to put it mildly, beyond our current technological capabilities. For starters, we'd need to find a way to create an infinitely long cylinder, which is, a tad challenging. And then there's the whole rotating at near light speed thing. But the fact that the laws of physics don't explicitly forbid the existence of a Tipler cylinder is, well, let's just say it's enough to keep those time travel dreams alive. Chapter 5. Quantum Tunneling, Leaping Through Time's Barrier. Let's venture into the quantum realm, where particles like electrons behave like waves of probability. Here we encounter quantum tunneling, where particles pass through barriers. Imagine a particle approaching a barrier and tunneling through it. Some physicists believe this might apply to time too. Could particles tunnel through time, leaping across temporal barriers? It's a tantalizing possibility, pushing the boundaries of our understanding. Chapter 6. Alcubierre Drive, Riding a Warp Bubble Through Time. Hold on to your hats, folks, because we're about to dive into the mind-bending world of warp drives and faster-than-light travel. In 1994, physicist Miguel Alcubierre proposed a solution to Einstein's field equations that seemed to allow for something truly extraordinary: a warp bubble, a region of spacetime that could contract in front of a spacecraft and expand behind it, effectively allowing the craft to ride a wave of distorted spacetime. Now, here's where things get really interesting. While the Alcubierre drive doesn't directly violate Einstein's speed limit, the speed of light, it does offer a clever workaround. By manipulating the fabric of spacetime itself, the drive could theoretically allow a spacecraft to travel vast distances faster than a beam of light, at least from the perspective of an outside observer. But what about time travel, you ask? Well, according to some interpretations of general relativity, traveling faster than light could potentially enable time travel. Think of it this way: if you could outrun a beam of light, you could, in theory, overtake the past. Of course, the Alcubierre drive faces some significant hurdles, not least of which is the requirement for exotic matter with negative mass, a substance that we've never actually observed. Chapter 7. Black Holes, Time's Cosmic Abyss. Let's journey now to the most extreme objects in the known universe. Black holes, regions of spacetime where gravity reigns supreme, where even light itself cannot escape the relentless pull. These cosmic monsters, formed from the remnants of collapsed stars, are shrouded in mystery, their very nature challenging our understanding of the cosmos. But amidst the enigma, one thing is clear: black holes warp time in ways that boggle the mind. Imagine approaching a black hole, its immense gravitational pull growing stronger with every passing moment. As you draw closer, time itself would begin to slow down for you relative to an observer at a safe distance. This effect, known as gravitational time dilation, is a direct consequence of Einstein's theory of general relativity. Now let's take things a step further. At the very center of a black hole lies the singularity, a point of infinite density where the laws of physics as we know them break down. What happens to time at the singularity? Does it cease to exist? Does it flow backward? Does it spiral into some unknown dimension? These are questions that continue to captivate and confound physicists. Black holes remain some of the most enigmatic objects in the universe, their secrets yet to be fully unraveled. As we conclude our journey through the mind-blowing possibilities of time travel, it's important to remember that the universe is a vast and mysterious place, full of wonders yet to be discovered. The concepts we've explored today may seem like science fiction, but they're grounded in the very real laws of physics, pushing the boundaries of our understanding of the cosmos. While we may not have time machines zipping us back to the dinosaurs, or catapulting us into the distant future just yet, the pursuit of understanding time travel ignites our imaginations, fuels our curiosity, and inspires us to keep exploring the universe and all its extraordinary possibilities. Who knows what breakthroughs await us on the horizon? Thanks for watching. If you enjoyed this video, Don't forget to like, share, and subscribe for more fascinating content. See you next time.